12:30 today like normal. And I'm going to be away from email most of the weekend, so you can try sending me an email, but just don't expect me to get back to you as quickly as I might normally get back to you. We're going to start and do one more problem on standing waves. Then we'll talk a little bit more about sound, intensity, and Doppler effects. So just a couple of new topics today. Let me remind you, if you haven't signed up for your mastery lab yet, you might want to schedule an appointment for sometime next week. Some of you have done it already, and the ones who have told me it works well. It's pretty quick. If you watch the video, get your data table made. It doesn't take you very long. It's pretty smooth. You'll be able to check your data. Once you run through the calculations, you'll know if you did it right. The experiment works just fine. It's just you'll need to write it up the way that we talked about in that handout that I gave you. Okay, so number one here says you've got a tube that's open only at one end. And a certain harmonic produced by this tube has a frequency of 1350 hertz. The next higher harmonic has a frequency of 1650 hertz. We give the speed of sound in air here to be 343. We want to know the integer m that describes the harmonic whose frequency is the 1350, and also how long this tube is. Okay. On this exam, I told you already that there's going to be something on the exam with the standing wave on a string, a tube open on one end, a tube open on both ends. So you should be capable of drawing pictures for all of them. I probably won't ask you for pictures for every single one, but I will ask you for some of them for diagrams. You should right away, once you have a tube and you know it's either open or closed, we have here the tube that's open only on one end. You have those set of equations for each of those three cases, the string and the two different tubes. First thing you should be thinking about is just, if you know you're doing a standing wave problem, it should be pretty clear that you have a string or a tube. You'll know exactly what to do with these problems. Draw yourself a picture if it helps. I'm just going to draw one here just to kind of remind ourselves of the first fundamental frequency, but that's not asked for here. I'm just drawing it to remind us here of the things that I'm thinking about, or that you should be thinking about when you're doing a standing wave problem. Just write all these equations down so you have them right there in front of you on the problem. I know some of you will write these down on the back page when I first give you the exam. Remember, you can do that, Brian? But to write them down, but right when you have it on the problem, just set up all these equations here, because we know here we can write an equation for the length. Remember, here we were adding up quarter wavelengths, so we can say this is m times lambda m over 4. The big difference here was that we were adding up quarter wavelengths, but these were only odd integers here for these m's. So we've got an equation for the length, we have an equation for the frequency, the fm is m times v over 4L. And we can always say that the harmonic frequencies or the resonant frequencies are all just multiples of the fundamental. This is m times f1. That's everything we know for a standing wave inside of the tube. We also know that v is equal to wavelength times frequency. But we've already used that to get from here to here, so generally you're not going to need this if you have these ones right here. So I would just start, get all that written down. The diagram you may or may not need, but I've just drawn it for the fundamental. We're not at the fundamental frequency here, or we don't know where we're at. I guess it could be the fundamental frequency, but we just don't know if it is or it isn't. Okay. Could it be the fundamental frequency, the 1350? Sure. Well, based on the second one that we have, which is the next one, could that be the fundamental if the next one is? Well,
No, because it would have to be at least.
if our first one was 1350, the next one, if that was the fundamental, would have to be 3 times that, and it's not, so we know that this one's not the fundamental frequency. Okay, so it's unknown. We want to figure out what m corresponds to our what do we say, 1350 here. For now, let me just call this FA. Okay, I don't want to put an F1 or F2 on it because those 1s or 2s always correspond to the number of the harmonic. I'm going to use an A and a B just to say we have two different frequencies here. We have a 1350 and what was the next one? 1650. And I think that's all we know other than the speed of sound and air here, which is 343. So we'll have that speed of sound there also. We want to know the M that corresponds to this frequency right here. Any suggestions on which equation to use for that?
What were we looking for again?
The M, the harmonic, the number that goes with this 1350 hertz frequency.
You could use,
The third one, couldn't you?
The third one here,
Yeah.
if we have F1, if we have the fundamental. So this is the F1 here, which we don't know what it is. I just drew it to show the two. We do know the wave speed. Do y'all feel stuck? Probably, right? Because I can't use an equation to get a number right away. But like you always do, when you're stuck, we can't always get our answers from one equation. So use multiple equations. And we have two different situations here. We have one here at this frequency. We have a different harmonic here at this one. Those are both numbers you have. You want to be able to use those somewhere. Just start setting up your equations. The nice thing about your standing waves is that really, if you write these down, this is all you have to work with. Now, on some of the ones on the homework, I might have given you a percentage relationship of increase or decrease or something. We might have given you the density of the wire. We did have a different wave speed for the strings, but this is what's describing the standing waves. And there's nothing else in here that we know. Whenever you're stuck, meaning that you look at an equation and I say right here, well, I can't solve for M because I don't know the L, for example, here, or I can't solve here because I don't know F1, you should still, at the very least, write down the equation that goes with each of these frequencies. Just set it up and then see what happens. Okay? So, even though I can't solve and get a number right away, which equation of the three here do you think would be most useful to set up with the information we've been given? The second one, because that has two of the quantities that we know in here. Okay? So let's write down that Fm is equal to, or not Fm, but let's just put it in right here with the Fa. Set it up here for this frequency. This is equal to M, which is unknown, times V over 4L. Okay. That's just the equation, but I put my Fa in there. And you could write the number in if you wanted to, but it's not going to get us anywhere just yet. Then how would I write this equation for FB if I'm going to do the same thing?
FB equals M.
Are the m's the same?
Bn plus 2, right?
Why m plus 2?
Because
You're
it's odd integers.
So this is the frequency of the next harmonic. The next one is always 2 more on these numbers here than the previous one. So this would be m plus 2 times v. Does the v change? Does the 2 change length?
no,
Okay, so this whole thing here, the v over 4L, is the same for both. What would the next higher harmonic be if we were talking about a tube that was open on both ends? Just be n plus 1 or n plus 1 if we're using the n's there. Everybody see why we did this here with the n plus 2? Okay. Now at this point, you have two equations, you have two unknowns, you should be able to solve for both unknowns. The m and the l is unknown. And now algebra. We can solve for the n first, since it asked for it in part A first, but if you solve for m and then eliminated that and solve for L first, it doesn't matter. We basically need to solve for the m that corresponds to this frequency here and the length of the tube. Okay. If we want to solve for the m first, anybody see what would be convenient here to do?
Solve for it over there.
solve for the m,
Mhm.
and then do what with it?
Plug it in over there.
If I solve for m and plug it in over here, then the m's gone. Then we can't solve for m. Now that would work to solve for L, and this is where when you're doing these, if you're solving for both things, it doesn't matter which order you do. But if you were saying, I want to try to solve for m right now, then you should be solving for the other thing and putting it in there so that you eliminate the thing that's unknown here that you don't want to solve for. Solving for m would work just fine to give me L. But notice here that this whole thing in parentheses is the same for both equations. So you could rearrange this and solve for L if you wanted to, but you could also just say FA over M is equal to V over 4L. And over here, FB over M plus 2 is equal to V over 4L. And you can rearrange and get rid of the 4 and get rid of the V or plug the V's in if you want to. But this is V over 4L and that's V over 4L. So what can we do now? Just set them equal to each other. You don't have to recognize that, it makes it much easier here if you do. Otherwise, really what you should be doing over here is solving one for L and plugging into the other one. But that's just a lot of wasted algebra, I think, in there. We can say now, just set these two equal. And then we'll have an equation with just the F's and the M's in here. This is FB over M plus 2. And then we have FA over the M. And how do we solve that for M?
Get M by itself.
By doing what?
Cross multiply.
Yeah, if you have a proportion, fraction equal to another one, you can just cross multiply here. Your FB times M is equal to FA times M plus 2FA. I just distributed that FA into the M and the 2 in there. Be careful with your math on these. I've been seeing a lot of mistakes with fractions, square roots, percentages, people just making math mistakes. I think if you go through all the homework, you'll get the practice you need, but at this stage now, we've got everything in here, right, except for the M. So you've got FB minus FA times M is equal to 2FA. Those are just numbers. You could have had them up here if you wanted to, but I'll just leave it like this with the variables. You've got 2FA then over the FB minus FA. What kind of number should we get for an answer here?
No.
Better be an odd integer or something went wrong. So this is 2 times the FA, which is 1,350. You've got FB, which is the 1,650, minus the 1,350 there again. And get some number here for M. Should get 9 here. Any questions about that? Yeah.
Does it work out like often to where you can, like break it down like that?
Like this?
Yeah.
Yes.
Is that one of those common?
In cases where you have the same tube with 2 different frequencies, you might be able to solve for something like that, where your V and your L will be the same. Not always, it just depends. The problems, you know, when it's just one tube, you have these and you work with just these, and I think those ones are easier. If you have more than one part, 2 different frequencies, or you have more than one tube, what you need to realize when you're doing these is when you have more than one situation, 2 different frequencies, 2 different tubes, whatever they are, just set up your equation for each one, and you'll find a relationship where you'll need to find a link between them. We've been doing that all semester long, where when you have multiple equations, you've got to find a way to put them together. And there are things like the L that might be the same. On those ones with the tension that we were talking about at the beginning, things like those mu's or the length of the string might have been the same for a couple different cases. And so you'll just make substitutions with things like that. on the practice problems, I gave you a problem where I think I have a tube that maybe is open on both ends or closed, I don't remember which way it is, but you cut the tube somewhere. So you have an original tube with some frequency. Then you cut it somewhere not in the middle, and you have two new tubes. Then you set up your equations for each tube, but the two tubes together need to have the length of the original tube. And these are all relationships that you should be able to figure out, but those problems are a little bit more challenging because they make you think. You're not just using the equation, you're not just plugging numbers in, okay? But on any of those, really, when you have these standing waves, every single different tube or different frequency you have, you can apply these equations to every different harmonic that you have, or every different tube or string. And so just work with these and set up your equations for each of the different situations here. Here was just two different frequencies. If it's just one, I think you've all kind of seen how, here's the physics all right here. If there's more, it's just more of putting this whole puzzle together. Okay. So the M we know, the L we can find for part B by doing what? Where can we get the L from? The length of the tube.
First equation?
This one? We could if we knew the wavelength. And we could get the wavelength from this if we wanted to. But remember, you won't have to use this usually if you have these right here.
Second one.
Wouldn't we just sub in
Yeah.
to the?
Go back to one of the ones over here, because that's where we were. We had two equations here with two unknowns, the M and the L. This is where you'll get both of your answers from. We could go back over here if we wanted to, but we'd have to take an intermediate step to get the wavelength from here first. But this equation's already kind of sitting in here in between these two. It's already been substituted in there. So you pick either equation here to solve for L. I'll pick this one because it's easier. So take this here, solve for L. We'll get what? L is equal to M times V over 4 FA. But we just learned that that FA goes with the ninth harmonic. So this M is 9 times 343 over 4 times the frequency here for A, which is the 1350. And then we'll get some length here for this too. 0.572. And you'll see here in the units how we have a meter per second on top, but this hertz is also what? How can I write that hertz?
Second.
1/2.
1 over seconds. So then if I have a meter per second over 1 over seconds, those seconds will cancel out. You just get meters in there for your units on the length. Okay. So that's it there. As I said, you'll have a few more for practice on the homework or that practice set.